this chapter covers user interaction, and it's broken up into a few sections. We'll get into what selection means in the Hoops Visualize world, how selection is handled. Talk about highlighting, which is related to selection but still distinct from it. We'll cover the concept of these operators that are supported by the component, and we'll have some code review along the way, and then finally we'll end up with an exercise which is really going through the selection and highlighting tutorial located in the documentation. So selection in Visualize is fairly extensive in terms of its capabilities, and Hoops Visualize also has a concept of selectability attributes. So when you do a selection refers to also picking on the scene or hit testing, saying, okay, I have a point or an aperture around the point, or maybe a selection region. It could be a box, it could be a polygonal area, it could be a polyline, it could be a selection cube, 3D selection box as well. And there's even a way to select by object. So I can have a shell and say select by shell. So tell me everything that this shell intersects with, which is actually a way for Visualize to provide collision detection. And so another part of selection is something we refer to as the event loop. And the event loop is driven by the sandbox GUI event methods that we suggest that people refer to and use as is when prototyping and starting to build their Visualize-based application. So if we go take a look at these events, we'll look at a sample method here for on-mouse move. And this is the MFC sandbox, so we've customized the main MFC view object. And the key magic that's happening in here is we're going to call on the canvas window key, there's a event dispatcher. So behind the scenes, Visualize can manage events and then dispatch them to, we'll see, operators that can be registered to respond to those events. And so we're going to inject event into the event dispatcher anytime the mouse is moving in our application. And to summarize, basically, we have information about this mouse move event. It's a mouse event, that's a move. We know the state of the mouse buttons. We know the actual GUI 2D pixel space point where this mouse move event has occurred. And then some additional flags that are also GUI-specific flags about kind of the state of the keyboard, for example. Was the control key down? Was the shift key down? So that all this event information is wrapped up and sent over to the dispatcher. And this is very clean because what it does is when you build one of these operators later on, and you tell an operator to respond to maybe a mouse move event, maybe a mouse down in motion to, so that means when we have a mouse move event, maybe one of the mouse buttons is down, maybe we want to use that to rotate or orbit the camera. And then we can write our operator in a very GUI and platform independent way, in a completely GUI and platform independent way. All we need is that our GUI specific mouse move methods or keep down methods are required to have this inject event. So you can just grab this code right out of any of the sandboxes and make sure that's in your application. So if we look at the right button down event, we have the same thing. We're going to just inject this event to our event dispatcher on the canvas window key. And what is the mouse event here? It's a button down, and we know that in this case it was the right button down. So we're going to specify that aspect of the event. Again, the XY pixel space GUI point where this event occurred, and some GUI flags, typically the state of the keyboard and whatnot. Okay. So when we talk about actually doing selection, this is achieved by calling one of the select by methods supported on the selection control object. And the input will be a series of mouse positions, I think all the time in window space, as I mentioned earlier, so there'll have to be a conversion from pixel space to window space. And we have the typical things you might expect, such as select by area. You can select by a polyline, called select by line. So I can digitize a polyline on the screen and ask Visualize to compute anything that falls underneath there. A single point, we will search not only under that point, but you can specify an aperture, a radial aperture to go out from that point. So it's really essentially a selection circular region around that point. And the other thing is fairly self-explanatory. Polygon, ray, I mentioned select by shell, and so on. Volume is going to be a cuboid volume. So what Visualize will do after you call select by one of these methods, it will walk through the segment tree, transform all selectable geometry up through its local object space, through world space, into window space, because these selection methods will have taken window space coordinates, and then we'll compare to the selected region and see if anything falls within inside or intersects with your selection information, your selection region. If there's many items, we will z-sort from front to back and give priority in the selection list that's given back to you, with the frontmost item working its way back. If you gave a selection point with an aperture around it, we'll first sort radially out from the aperture, and then, that's the priority, and then we'll sort from front to back. You can read the different select by methods for more details about how we prioritize the selection list given back to you. And similar to how we would iterate over search results, we'll iterate over selection results as well. So you have a list, you'll get an iterator, and you'll loop through these items. And on each item in the selection list, you'll make some decision about what to do with it. Query it, delete it, edit it, highlight it, move it around. That's up to how your application wants to handle dealing with selected items, depending on the mode that it's in. It might involve orbiting the camera, or panning or zooming, or something like that. Okay. So the selection process has a lot of control. Here we're seeing 3 examples of the selections options control class. We can control the selection level. Do I just want to select on segments down through the scene graph? Do I also want to select on entities and also consider sub-entity information? Depending on what you choose there, can have Visualize do extra selection processing work, or it could optimize it if you don't really care about going down into sub-entities. By sub-entities, meaning I say I draw a selection box, and maybe I only want to select on just what entities might have fallen in the selection box, just any pieces of them. So I could just say entity level. If I also wanted it to select on sub-faces, vertices, and edges of shells, then I could say also do sub-entity selection. We'll do extra processing and give back a list of sub-entity information. Proximity I mentioned earlier. When you're doing select by point, you can control radially how far out. This is important because if you are in a select by point mode, and I just want to be like picking on, let's say, specific edges, well, if you had 0 proximity, that means you'd have to precisely pick exactly on the pixels of an edge to be able to select it, which would be very, very difficult. So usually a selection proximity for a single point would be maybe a ½ centimeter or the equivalent in window space, so that you allow the user to pick close to an edge, but not precisely on it, but still be able to pick it. So it's fairly user-friendly. So selection proximity is another control that you have. And the third most significant control over selection is the algorithm. Analytic is the default. That means independent of what is happens to be visible on the screen, we will go back and do a selection in analytic 3D space. So if I had a sphere on the screen and then a large box behind it, and I pick right in the middle of that sphere, we're going to pick and return to you both the sphere and the box, even though the box might not have been visible underneath that. Sometimes it's interesting to only be able to pick on things whose pixels are currently visible on the display, and that would be the visual selection algorithm. It's a little more computationally intensive because we actually have to we'll do a selection render of the scene, but that's done with hardware acceleration. We'll do an off-screen selection render so we can pick off of the kind of image buffer. And then I mentioned this earlier as well, there's a selectability control that determines which aspects of geometry is selectable. So you could say, I want faces to be selectable, but not edges, vertices, or lines, or vice versa. So you could be in wireframe pick mode only be able to pick on edges and lines and text, or maybe you only want to be able to pick on actual facets. Okay.
Well, is there a default, or do you have to set everything?
There's defaults for everything. Yeah. So, for example, the selectability control, I believe everything is selectable to begin with. So if you had geometry in a segment that you didn't want anything to be selectable, you could actually just say selectability control, selectability, everything equal off, or the enumerated type for everything off.
So default is on?
Yeah, the default would be here. If we look at the selectability value, we have off, on, forced on, which is interesting. So that lets you make it selectable even if not visible. By default, if something is not, how should I say this? By default, if something is set to be not visible, so set visibility, not if it's hidden by something, but you said set visibility, blah is off. You've specifically made it not be drawn. By default, that will also not be selectable. You can actually tell Visualize to make things selectable even if I've explicitly made them invisible. That could be useful at times. That's not to be confused with if something was just obscured and hidden and the pixels aren't visible and you want to be able to not select on those things, that's the algorithm, analytic versus visual. Okay. And I mentioned this previously. We can get into a little bit of a example here. We can get selection results back. That gives us the list of selected items. We'll have an iterator to go through them. And then selection item gives me details about each item. And if I go and look at 632A and scroll on down, I think we have an iterator here, 632B. Our ITER is our iterator for our selection results. We operate through that and we call get item for each one. We get a selection, HPS selection item. And then when I have a selection item class, I have a variety of methods to show information about that item. In this case, I'm getting the key of the item. Of course, once I have the key, just like in a search, I can see what kind of key type it is, and I could do whatever. I could query information of the points array of that key. I could edit that geometry. I could delete that geometry. I could highlight the geometry, and so on and so forth. Okay.